Welcome, students, to the next lesson in 8th grade Eureka Math. We are in Module 3, and today is Lesson 6. Lesson 6 is all about dilations on the coordinate plane. In other words, we're graphing dilations. We introduced some of these ideas yesterday in Lesson 5. We're going to expand them and work more on them today with pages 59 through 71. So make sure you have those pages with you. Make sure you are copying down the notes. Make sure you have all the supplies you might need. I don't know if you'll need a ruler today, but always might come in handy. Also, if you use different colored pencils or different colored pens, make sure you have those next to you. You'll hear mine moving around during the whole lesson because I use a bunch of different colors to try to make things a little bit more clear. So far, what have we learned? Well, we talked a few lessons ago about the fundamental theorem of similarity, or we abbreviated it FTS because that's a lot to write about. In your notes, if you just want to write FTS, you can. FTS showed us how the scale factor changed every length in a dilation. Scale factor changes every length in a dilation. Every length is changed. All sides, all segments, all lines are changed in a dilation by the same scale factor. The thing that does not change in the scale factor are the degrees of the angles. The angle degrees do not change, but the lengths do change. And yesterday we also started dilating on a graph. We specifically dilated points on a graph. You moved points around. In fact, the first thing we're going to look at today after our notes is yesterday's exit ticket, and we're going to see how you dilated points. So yesterday we started dilations on a graph with just points. Today we're going to do more graphing dilations, but we're going to graph figures and shapes. So it should be a little bit more fun today, because you can actually draw some shapes. Today, we will dilate figures, not just points, using the scale factor, using the coordinates, and using the dilation equation. So you're going to need to use all three of those. The scale factor, we've learned about in this module. The scale factor is R, what everything gets multiplied by. Coordinates are like coordinates on a graph. So ever since you started graphing things with coordinates, you should know what those are. As a reminder, they look like this: parentheses x, comma, y. That's how we write coordinates. So we're going to be looking at coordinates using them today. And the third thing you're going to need to know today is the dilation equation, which we've been talking about for a few lessons now. The dilation equation is this: the original multiplied by the scale factor, the dilation equals the original multiplied by the scale factor. The dilation equals the original multiplied by the scale factor. That's in words. If you want to know it in symbols, A prime equals A times R. A prime is the dilation, A is the original, R is the scale factor. So the dilation equals the original times the scale factor. So that's what we'll need today. We'll need the scale factor, we'll need coordinates, and you will need the dilation equation. This is a little preview of the math we'll be doing today. This is how we dilate with coordinates. So we start with the original coordinates right here. The original coordinates are x, comma, y. The dilation equation tells us that a dilation equals the original times the scale factor. And so when we do the dilation equation with coordinates, what we need to do is we need to take the coordinate and multiply by r. So the dilation coordinates are x prime and y prime. Original are x and y. After the dilation, we call them x prime and y prime. How do we find x prime? We do x times r. How do we find y prime? We do y times r. And this is because of the fundamental theorem of similarity. This is because of FTS. Because remember, everything changes by FTS. So FTS tells us all the lengths change. So X and Y change. X and Y change also. And FTS tells us they change using the scale factor. So when we dilate a coordinate, we multiply the pieces times the scale factor. X times R makes X prime. Y times R makes Y prime. And so when you dilate shapes on a coordinate grid with coordinates, you do not need to do what we did for the beginning of Module 3. You do not need to draw a bunch of lines and get your ruler and measure. That's unnecessary. If you are graphing on a coordinate grid, you just dilate the coordinates. You do not have to dilate the whole shape. You dilate the coordinates. So let's look at what we've done before. If you remember, when we dilated an oval, you had to draw a bunch of these orange lines, and you had to use a ruler to measure it and figure out where the new one was. But on a graph, you don't have to do that anymore. On a graph, you can just type the coordinates into this equation, put the coordinates in that equation, and you can find out where everything goes. Kind of like what we did in the exit ticket yesterday. Let's look at the exit ticket yesterday that you worked on. This is your exit ticket from yesterday where you were supposed to find A prime. You dilated A to find A prime. And so what we did yesterday is just for one point, you found X and you found X prime, you found Y prime. What you did, you took the R 6/4, you multiplied by 3, you multiplied by 4, and you found out that 3 times the scale factor was 4.5, so X has to be 4.5, and 4 times 6/4 is 6. So the new one goes right there. 4.5 and 6. That's what you did on the exit ticket yesterday. That's what we're doing on the lesson today. We are dilating coordinates using the scale factor. So right now, take a little bit of a pause, take a little bit of a break, go back and finish whatever notes you have to work on. If you did not copy down all the notes, copy them down now. If you still need to get some materials, get your materials. And when you unpause the video, come back. We're ready to work on exercises 1 through 5 on page 59. You should be all caught up with your notes. You should be ready to go. Thank you for unpausing and continuing to work. Let's look at page 59, exercise 1. We need to dilate a point. So it says point A, coordinates are 7, 9, and remember coordinates go X, Y, because X comes first in the alphabet. So X comes first in the coordinates. Point A is dilated from the origin by a scale factor, R equals 6. What are the coordinates of A prime? So we have A, we have the scale factor, and we have A prime. So we are going to use the dilation equation, the coordinates, and the scale factor to find A prime right here. So if you look at this, to find A prime, we need to do X times R and Y times R. So let's write this down. We know A is X times Y. We know A prime is going to be X prime, comma, Y prime. How do we find this? Oh, well, we know A is x times y, and we know A is also 7, 9. That's what we know. So how do we find A prime? We need x prime and y prime. So we do A prime equals r times x, comma, r times y. So r, we know they told us it's 6. So, and x, the original A is 7. And then, so that tells us the x, and the y is going to be r times y, which is 9. So 6 times 7 is 42. 6 times 9 is 54. So that is A prime. And that is how you do it. And the reason you can do it just like that simple, is because remember, FTS tells us the scale factor changes everything. So because the scale factor changes everything, the scale factor changes x, the scale factor changes y. So you just do 6 times x, 6 times y, and that tells you the dilation. That tells you where the new point is. Let's do another one, this time with an r factor of 1/2, a fraction one. So this time we have point B is -8, 5, dilated from the origin by a scale factor of r equals 1/2. And we need to find B prime. So let's go to work. Let's say, well, B is going to be x times y, no prime. And B, they tell us, is -8 times 5. And we know B prime is going to be x prime and comma y prime. We just need to find what x prime and y prime are. But you know the fundamental theorem of similarity tells you the scale factor changes everything. So when we find B prime, we know we multiply x times the scale factor, and we can multiply y times the scale factor, because the fundamental theorem of similarity says so. So after you have this, now you just have to substitute what you know. The original x was -8. The scale factor is 1/2. The original y was 5. The scale factor is 1/2. And now it's just a multiplication game. -8 times 1/2. What is 1/2 of -8? Half of -8 is -4. And then we have to do 5 times 1/2, so half of 5. Well, it's not going to be a whole number because 5 is not an even number. So you can only cut even numbers in half evenly. So it's an odd number. So you know 4, you know half of 4 is 2 and half of 6 is 3. So half of 5 is going to be 2.5, 2.5. So that's your answer for that one. The hardest part for you, I think, on these is going to be multiplying maybe with the fractions. But because fraction multiplication might be a skill you haven't practiced in a while, but you can do it. You just take some practice. So that's how you do it, because the FTS tells us the scale factor changes everything. The scale factor even changes coordinates. So I did 1 and 2. I'm going to keep going to do 3, 4, and 5. But if you feel confident, what I'd like you to do is I'd like you to work ahead of me. If I'm going to be talking about everything I do, so I work slower. So what I would like you to do while I'm working and while I'm talking, if you feel comfortable, work faster than me. Find the answers before me, and then you can check when I'm all done. So I'm going to start number 3. And because I've been talking a lot, maybe some of you are already done with number 3. That's good. So you can keep working, and I'll show you all the answers at the very end when I'm done. If you do not feel comfortable working ahead, if you still want me to help you a little bit more, you can just follow my pace and work with me. So number 3, this time we have point C, which is 6 comma negative 2, is dilated from the origin. Oh, one thing I want to point out. Very important. All of these say dilated from the origin, dilated from the origin, dilated from the origin. Always pay attention to where you are dilating from, because it makes a big difference if you are not dilating from the origin. If you are not dilating from the origin, it changes things. So always check where the center of the dilation is. If the center is at the origin, you do it just like this. And I think all the questions today are going to be dilated from the origin. But as we work further into Module 3, the center of dilation is going to change a little bit. Just be prepared and always check. Anyway, point C, dilated from the origin by scale factor r equals 3/4. What are the coordinates of point C prime? So let's write down what we know. We know that C means x comma y, and it is 6 comma negative 2. We also need to find C prime, and we know C prime is going to be x prime y prime. And we know we find C prime when we take the original and multiply it by the scale factor, because that's how all dilations work. All dilations are the original times the scale factor. So we do the original times the scale factor for x, and we do the original times the scale factor for y, and we put in what we know. We know x was 6, we know r was 3/4, we know y was negative 2, we know r is 3/4. Now it is multiplying, and so you will have to do your multiplication skills on this one. If you multiply fractions, you find out that x prime is going to be, let's see, 4.5, I believe. Let me check that. Yeah, 4.5. And this is going to be -3/2, or -1.5. So those are the answers. Now, if you need to practice your multiplying of fractions, let me show you how I did these with multiplying of fractions. 6 times 3/4 has to be 6/1 times 3/4. Because when we multiply fractions, we need fractions. So 6 needs to turn into a fraction, just put on top of 1. So I have 6 times 3 on top of 1 times 4. Now 6 turns into 2 times 3, because 2 times 3 makes 6. And 4 turns into 2 times 2. And now I can simplify before I multiply, because I see a 2 in the numerator and a 2 in the denominator. So I can cancel a 2, because 2 divided by 2 makes 1, so it goes away. Now what I'm left with is 3 times 3 and 1 times 2, which is 9/2, which can be turned into the mixed number 4.5, because 9 divided by 2 is 4, with 1 piece left over, 4.5. That's how we multiply fractions. So you might need to do a little bit more practice with multiplying fractions on this. So do your practice and check your work with mine. And if you are still having trouble, talk to me and we'll set up a tutoring session for me to help you. Okay, let's look at number 4. Some of you are probably already done with number 4. We have point D, which is 0, 11, dilated from the origin. Important. Scale factor r equals 4, and we need to find D prime. So let's go to work. We know, let's write down what we know. We know D is the original x comma y, and we know that is 0, 11. We know D prime is going to be x prime and y prime. And we know that x prime is made when we do x times the scale factor. and y prime is made when we do y times the scale factor. Now we just use the information we have to solve and find d prime. X is 0, and r in the question tells us it was 4. Y is 11, and r again is still 4. Now this is not multiplying fractions, so you should be able to do this pretty simply. 0 times 4 is 0. 11 times 4 is 44. So d prime, the coordinates of d prime, 0, 44. Simple as that. Just remember the scale factor changes everything. Try one more, number 5. Point E is -2, -5, dilated from the origin. Scale factor r equals 3/2. And we need point E prime. That's what we need. So let's go to work. We know first, we'll write down what we know. We know E is the original x, y, and we know that is -2, -5. We know E prime is going to be x prime, y prime. And when we find how do we make x prime, we do x times the scale factor. How do we make y prime? We do y times the scale factor. Now you put in the stuff you know. X is -2, r is 3/2. Y is -5, r is still 3/2. Now we need to multiply, and this is fractions, so you're going to need to multiply fractions. -2 times 3/2 turns into -3. -5 times 3/2 is -15/2. You can also say it is -7.5 if you want. So you can write it like that, or you can say -3, -7.5. Both of those are correct. So those are the answers to exercise 1 through 5. You got a little bit of practice doing this with individual points. On the next page, we're going to start doing these with making a figure. Because right now on this page, we did point A, B, C, D, E. But what happens like on page 60 if A, B, C form a triangle? What happens to the triangle? So so this was practice with points without seeing a picture. I want you to pause the video, maybe take a little break, check your answers with mine, and then we'll come back and we'll talk about actual figures and actual shapes. This was just practice using the equation. If you finish before me, let's check the answers. A prime for number 1 was 42, 54. Number 2, B prime, -4, 2.5. Number 3, C prime was 4.5 and -1.5. Number 4, D prime was 0, 44. And number 5, E prime was -3, -7.5. So pause the video, take a little bit of a break, and then come back and we'll work on page 60 and we'll see what this does to real shapes. Welcome back, class. Hopefully you got to pause the video a little bit, take a little bit of a break, and check your answers for the first 5 exercises. Let's move on to exercise 6, where we actually see the shape that we're working with instead of just points and numbers. For this one, we have a triangle. And let's read the directions. The coordinates of the triangle ABC are shown on the coordinate plane below. So this time they did not give us the coordinates. We had to find them ourselves. The triangle is dilated from the origin by a scale factor r equals 12. Identify the coordinates of the dilated triangle. So we need to tell the dilated triangle ABC. So the first thing we need to do is write down what we know. We know, I'm just going to do my work on the bottom part of the page. So we know, first I'm going to write right here that r equals 12. That is going to be true for everything. because remember, scale factor changes everything. Now I need 3. I need A, B, and C. So let's do A. I'll do in orange. B can be blue. And C, point C, I will do in red. Now, the first thing I want to do is I want to find the coordinates of the original. So let's look at A. If I start with A and go down to the x-axis, here's the x-axis right here, A hits -2 on the x. And A hits 2 on the y. Here's the y-axis. I go over and it's lined up with the 2 on the y. So A is going to be -2, 2. B, here's B down here. I'll make that blue so you can see. I should probably do the same thing for A, make it orange so you can see. And C will be red over here. There we go. Where does B go on the x? Well, here's the x-axis. I go up to find it. It's at the -3 point. So -3 on the x, and it looks like it's -3 on the y also. C, here's C. On the x, it's lined up with the 6 on the x-axis, and it's lined up with the 1 on the y-axis. So now I have the coordinates, I have the information I need. Let's use that. So I know I have A, I have B, I have C. I know A is -2, 2, but I don't care about A. I really want A prime to figure out the dilation of the triangle. Well, A prime is going to be x prime, y prime. How do I find x prime? Well, we practiced this on page 59. You know that this x prime is going to be x times r, and y prime is going to be y times r. Now we put in what we know. We know x was -2. We know r was 12. I wrote it right there. Y was 2. The original was 2. R is still 12. So A prime is going to be -2 times 12, which is -24, and 2 times 12, which is 24. So those are the coordinates of A prime. -24, 24. If you notice, this is exactly what we did together on page 59. This is exactly what we did, except for this time we know this point is talking about a triangle. And we just did the exact same thing with point B. We need to find B prime, which is going to be x prime, y prime. And we find x prime by doing the original times the scale factor, the dilation equation. And the y prime is going to be the original times the scale factor, which is from the dilation equation. Then we just put in what we have. X is -3. R is 12. Y is -3. And R is 12. So B prime, the coordinates for B prime are going to be -36, -36. After the dilation. Before the dilation, after the dilation. Before the dilation, after the dilation. A triangle has 3 vertices, so we still need to do point C and find C prime. C prime is going to be x prime and y prime. And how do we find y prime? We use the dilation equation, and we do the original times the scale factor. How do we find y prime? Use the dilation equation, original times the scale factor. Put in what we know. We know x was 6. We know r is 12. We know y was 1. We know r is 12. And so C prime's coordinates are going to be 72, 12. And those are the 3 points. We have the up top, we have these before the dilation. And these on the bottom are the coordinates after the dilation. And we could even graph these if we wanted to. We could even find the new triangle. The only problem is this graph right here is nowhere near big enough to find the new triangle. I mean, we got points. We need to go 24, negative 24, negative 36, negative 36, 72, 12. None of those will fit on this graph. The scale factor was so large, we cannot even graph the new triangle. So let's maybe find one that we can graph the new one of. Let's look at page 61, exercise 7. And this is one that we are going to draw after the dilation. So let's look at this. We have figure DEFG. So this is a quadrilateral. It has 4 sides and it has 4 vertices, which means we're going to need to find 4 prime points. This figure is dilated from the origin by a scale factor r equals 2/3. And we need to find the dilated figure, and we need to draw and label the dilated figure. So that's an extra step. We need to draw and label it this time. So let's get to work. We have 4 points that we need to dilate. Now, usually what you might do is you might draw lines and try to dilate. But remember, today we found out that we can just use the coordinates to dilate. So I'm going to need 4 colors this time because we have 4 points. I'm also going to write down the scale factor right at the bottom so that we can all see it when I'm doing all my work. And we have points D, E, F, G. So let's go with point D, point E, point F, and point G. I'm going to try to do all the work on this piece of paper. If you need to do your work on a separate piece of paper, that is okay. I'm just doing it right here underneath because I think I can probably fit it. If it doesn't fit, I'm going to look like a fool, but I'm used to that. So the first thing we need is we need to find the coordinates for all of these points. D is -6 on the x and 3 on the y. So it's -6, 3. And because here's D right here. E is down here, and those coordinates are -4 on the x and -3 on the y. Point F is over here, and those coordinates are going to be, let's see, 5 on the x and -2 on the y-axis. Our final coordinate is G. It's up here close to the D coordinate. Those coordinates are -3 on the x and 3 on the y. So those are my 4 coordinates that you need. Now we need to change them to the prime coordinates. Let's start with D. Let's find D prime. You know D prime is going to be x prime or y prime. And yes, I am showing all the work. I would like you to show all the work too. If I can do it, you can do it. So those above my underlining, I'm underlining what is true before the dilation. And now underneath right here, I'm doing the work after the dilation. So x prime is going to be x times the scale factor. Y prime is going to be y times the scale factor. I know my scale factor is 2/3, so let's do some work. X is -6 times 2/3. Y is 3, and I do that times 2/3. So -6 times 2/3 is going to be, okay, that something moved on my table. Sorry about that. Something just popped down. I'm going to check that out later. But we can still see on the screen. We're good. -6 times 2/3 is going to be -4. And 3 times 2/3 is going to be 2. So that is where D prime goes. Let's look at E prime. E prime, again, is going to be, I need prime for both coordinates. And I get the prime coordinates by multiplying them both times the scale factor, just like that. Now let's put in what they are. X was -4, and the scale factor is 2/3. Y was -3, and the scale factor is 2/3. So E prime is going to be, let's see, -4 times 2/3 is going to be -8/3, which is about 2 and 2, which is 2 2/3. -3 times 2/3 is going to be -2. But once again, if you need help multiplying by fractions, reach out to me. Maybe find a lesson on Khan Academy or find a lesson on MobiMax. But you do need to know how to multiply by fractions this year. So get to practicing. 2 more coordinates. We need to find F prime, which is still F prime means the X and Y are also primes. And we find primes by multiplying by the scale factor, because FTS tells us everything is multiplied by the scale factor. We substitute. We put in the information we have. X is 5, R is 2/3, Y is -2, R is 2/3. So F prime is going to be 10/3, which is 3 1/3. And Y prime is going to be -4/3, -1 1/3. So those are the coordinates of F prime. One more coordinate to do. We need to do G, and we need to find G prime, which is X prime and Y prime. And how do we find X prime? Well, we do the original times the scale factor. How do we find Y prime? We do the original times the scale factor. Substitute with what we know. We know X is -3. We know the scale factor is 2/3. We know Y is 3. And we know the scale factor is 2/3. We do our multiplying fractions, and we get -2, 2. So those are the 4 coordinates. We found the 4 coordinates. But remember, the directions said we need to draw and label the figure. So let's draw and label. D prime is -4, 2. So I'm going to go to -4 on the X, 2 on the Y, and that is D prime. E prime. This is -8/3, which is -2 2/3, and -2. So I go -2, and I go about -2 is right here. So -2 2/3 on the X is about right here. So about right there. And then I go -2 on the Y. So we're looking at about right there is going to be E prime, because it's 2 2/3. So it's not going to be exactly on one of those lines. F prime is 10/3 and -4/3. Now 10/3 is 3 1/3. So I go 3 1/3 of the next box. And I go -1 1/3. So F prime is going to be about right there. That's going to be F prime. G prime is -2, 2. So I go here. -2 on the X, 2 on the Y, and so G prime is right there. Now what I should do is I should get my ruler so that I can draw. I can connect my prime dots so you can see the prime figure. Connect the prime dots so you can see the prime figure. And there it is right there. That is DEFG prime. You knew it was going to be smaller because the scale factor was a fraction. And so that is exactly what yours should look like. If you did all this work, all the work on the bottom there is so that you can find the coordinates. And then after you know the coordinates, you plot the coordinates, you graph them, you connect the coordinates, and you see that you have a similar quadrilateral, only a little bit smaller. And that is exercise 7. We have one more practice exercise we're going to do. So go to page 62. We have exercise 8. And this one, they give you no drawing. In fact, you have to draw it yourself. You have to start by drawing it yourself. So this is working from scratch. They do give you the graph, but it says, but let's do this one step at a time. It says triangle ABC has coordinates A, B, and C. First thing we need to do is draw and label triangle ABC. So let's do that. Let's take point A. It's 3, 2. So 3x, 2y. Here's A. B is 12, 3. So that's 12x, 3y. So this is point B. And point C is 9, 12. So that's 9 on the x, 12 on the y. So point C is up here. So those are the 3 points that they gave us in the directions. Now I need to connect them to show triangle ABC. So I'm going to get my ruler to make sure I can do straight lines. And I'm going to draw the 3 sides of this triangle. And there's the triangle that you should have. Everyone should have the same triangle. So that was the first line. I drew and labeled the triangle. Now the triangle I just made, triangle ABC, is dilated from the origin by scale factor r equals 1/3. So the scale factor r equals 1/3. Now it says identify the coordinates. So I need to find the coordinates. I need to draw the coordinates. Oh, you can't see my directions. There we go. Identify the coordinates, draw the coordinates, and label the triangle. So those are 3 things I need to do. I need to find the coordinates, draw the coordinates, and then label the triangle. Let's do those. So I'm going to need these 3 coordinates, the originals before the dilation. So A, remember the coordinates for A, it says in the directions, 3, 2. Before the dilation, that's where A was. Before the dilation, B was 12, 3, before the dilation. And C before the dilation was 9, 12, before the dilation. Now I need to find all of those after the dilation. I need to find the prime coordinates. Let's start with A prime. And this is exactly what we've been doing all day. A prime is going to be the new x and the new y, x prime, y prime. We find x prime. Remember the dilation equation. We do the original times the scale factor. And y prime is also the original y times the scale factor. And now we just substitute what we know. We know x was 3, and we know r, they told us in the directions, is 1/3. We wrote it down just to make sure. We know the original y was 2, and we know r is 1/3. So now we multiply our fractions. 3 times 1/3 is 1. 2 times 1/3 is 2/3. So that's A prime. A prime is going to be those coordinates. B prime, we're going to follow the same pattern. We need to find x prime and y prime. We use the dilation equation. Original times the scale factor makes x prime, and the original y times the scale factor will make y prime. We substitute what we know, like x for b, the original x was 12, multiplied by the scale factor 1/3. The original y was 3, multiplied by the scale factor, which is 1/3. We multiply our fractions. 12 times 1/3 is 4. 3 times 1/3 is 1. So we have the coordinates of b prime. We just need the coordinates of c prime. C prime is still going to be, we need the new x and the new y. The new x is the old x times the scale factor. The new y is the old y times the scale factor. We fill in what we know. The old x was 9. The scale factor is 1/3. The old y was 12. The scale factor is 1/3. 9 times 1/3. The new x is going to be 3. And the new y, 12 times 1/3, is going to be 4. So now we have the prime coordinates. There we did the first thing. We did identify the coordinates. We did that. Now we need to draw the coordinates. So let's go back up to our graph. A prime, our new coordinates were 1 and 2/3. So we do 1 on the x, 2/3 on the y, and that is where we put A prime. B is the B prime, the coordinates are 4, 1, which is 4 on the x, 1 on the y. So B prime goes right there. C prime, the coordinates were 3x, 4y, so 3 on the x, 4 on the y. There is C prime. So I found the coordinates. I drew the coordinates. Now I need to draw the triangle. I labeled, I found, I identified, I labeled. Now I need to draw the new triangle. So I'm just going to connect using my ruler to make sure my lines are straight. I'm going to connect my prime points. And you see I have my itty bitty baby triangle. It is the same triangle, just a different size. All the angles are the same. It just shrunk by the scale factor 1/3. This is 1/3 the size of that one. And that's how you do a dilation using coordinates. It does take math. You do have to use the dilation equation, but it is absolutely possible. You just have to do the work. Let us talk about the lesson summary just tells you what we just worked on. Dilation, it says has a multiplicative effect on the coordinates, which means dilation multiplies the coordinates. Dilation multiplies the coordinates. And this right here, Rx, Ry, that's exactly what we did. So this is just summarizing what we did. You can look at that. The exit ticket we'll talk about last. The exit ticket is on page 65, but I'm going to slide that to the back of my packet because that's the last thing you do. The homework helper is on page 67. If you need another example of how to do it, I mean, we did a lot of examples together, but here's another example on page 67 of the homework helper about how to find the dilated coordinates of this triangle. So that gives you a couple more examples, 1 and 2, about how to do this if you need that again. But your problem set starts on page 69. And this is exactly what we've done before. This is exactly what we did today. It says triangle ABC is shown on the coordinate plane below. The triangle is dilated from the origin by a scale factor 4. Identify the coordinates of the dilated triangle. So this is just asking you to find the coordinates. You do not have to draw. It just says identify the coordinates. So this is going to be like number 6 on page 60. If you want ideas about how to do this, number 1 in your problem set is like number 6 on page 60. On page 70, your problem set continues, and they give you a triangle, and it says it's dilated by the scale factor 5/4. This time it says, this time it also says identify the coordinates. So it does not say draw. You do not need to draw this one either. So this one is also going to be like number 6 on page 60. Problem set number 3, the triangle ABC has these coordinates. The triangle is dilated from an origin by a scale factor r equals 1/2. Identify the coordinates. So you don't have to graph this one either because it does not tell you, it does not show you the graph. So this is just, can you find the coordinates without looking at it? Again, you don't need to see it to find the prime triangle. This is like number 6 on page 60 also, just you don't see the triangle. If you need to see the triangle, you can always get a piece of graph paper and draw it yourself. Your problem set, last page of your problem set is page 71, and this time you are going to find the coordinates, draw, and label. You're going to find the coordinates, you're going to draw and label this one. So this is just like what we did. You've done this before. If you need to know, if you need help on this one, it's like number 7 on page 61. Same type of thing. And the last problem set question, they give you original coordinates and they want you to just identify the coordinates. So you don't need a graph for number 5 either. You don't need to draw anything. So this will be like page 60, number 6, because you don't have to graph that. So that's your problem set. Here is your exit ticket, which is on page 65. Number 1 says, the point is dilated by scale factor r equals 3. What are the coordinates? So you just need to tell me the new coordinates after the dilation. We did this a lot. You can find that. And for number 2 on the exit ticket, you're going to have to, well, they do not give you the coordinates, so you have to find the coordinates yourself. They do give you the scale factor. And they want you to, what is the location? In other words, what are the coordinates? So you need to find the coordinates. You need to draw and you need to label this one. So you're doing everything for that one. But that is your work for the day. We did a lot of practice together. Hopefully it's clear. Hopefully you know what you're doing. If you need anything, remember, I am here all day ready to help you out. Just send me an email, get me a message, and we can do a private meeting, and I can even do one of the problem set questions for you. So if you need anything, reach out. If you do not need anything, have fun. Remember to take a picture of your exit ticket when you're done. Turn it in on the Google Classroom. Also remember my answers to the problem set are on the Google Classroom to help you if you need that. Have a great day, and I'll see you for the next lesson.